Welcome, everybody. We're going to be working on Unit 7 this evening. Unit 7 covers Chapter 8 in our book. We also have some auxiliary materials from some websites that we have been using for reference. And the topic for tonight is data types. And, the strange thing is we started out the semester just kind of running queries, uh, not really necessarily building databases so much, but, you know, using databases that are already constructed, and you run into the topic of data types even before we formally talk about it in the course. I think it's a little strange, frankly, and I'm just saying this is maybe a slight critique of the book, because normally when I start thinking about creating databases, the first thing I think about are the columns in the database tables and what kind of information they hold, right? And to me, that feels a little bit more primary than waiting until chapter 8. So this is my critique, right? So you take that for what it's worth, but I am following the sequence of the course development and the book development, which kind of gets you coding, querying, etc. And now we're kind of being confronted with this concept of data types, and we're going to dig into it a little bit more deeply tonight than we have in the past. Now, I consider this a very fundamental aspect of databases, just like I consider it a fundamental aspect of working with a programming language, where you need to know the data type of what you're working with in order to manipulate the information correctly and deliver the content correctly, right? And store the information correctly. So this is kind of a little, I guess, preview of what we're about to talk about. Now, I'm going to use the two different reference sites that I have listed here, and talk about like some of the materials in general. I will take a quick look at the author's PowerPoint. I think, real frankly, it's highly unclear, but I'll hit on a couple topics in there that I think are useful. But the main focus is going to be on these two reference websites here. I'm just going to go ahead and dig in. I'm going to start with the W3Schools site here tonight. So I'm going to right click and open that in a new tab. And I'm taking this right to their page here. And they have a whole section on this. And you'll notice they have it under a section called references, right? All right. So let's look at like their just quick definition right up here at the top. And I'm going to read this to you verbatim. And it says, the data type of a column defines what value the column can hold. For example, an integer, a character, money, or financial amounts, a date, time, binary information, and so on. Every column in a database must have a data type declared. So you can't like not have a data type. And what you choose to create as a data type for a column depends on the information that's going to be stored there, right? So for those of you also taking programming classes, and I have like a high percentage here that are in my Python class that follows, but I also have this assumption that some of you might be brand new and maybe never have coded before. But even in a programming language, when we develop what we call a variable, we're thinking about the data or the type of data that goes into that variable. Now, when we use Python as an example, which is not a great example because Python is what we call a not strongly typed language. In other words, in one instance, I can put words in a variable, in the next instance, I can enter a number. And Python's okay with it and rolls with it, right? Dynamically adjusts. Databases, by their nature, the way they're built, do not dynamically adjust, right? It's not that they can't be adjusted, but it's kind of more like, we built the house. This is the house. We're not, going to tear down the whole house just because you decided, that the room should be in a different place now, that kind of thing. So it's one of those things where a lot of forethought goes into this. And I think this is one of the reasons why they push it so far into the book, because as you get to understanding how a database operates and how you can query it and extract information, and then you start thinking about the reverse aspect of it, which is to build the database rather than to utilize it. It does take a lot of forethought and planning to make sure that you put the right kind of data in the right kind of fields for the right kind of reasons. So for example, if I'm going to build a table that has a person's personal information in it. And typically that will start with their name, right? First, last, middle, initial, right? What kind of information is that? I mean, that's kind of a no-brainer, right? Those are characters, basically. Or if you think of it from a programming standpoint, a string of characters, right? Is there ever a time where a first name would probably be a number? Not maybe if you were a robot, no. The answer would be no. So that's not a good fit. But there are other times where it makes complete sense to store numbers. The problem with numbers is numbers have different size capacities. So in other words, a number might be anticipated to be small, or a number could be anticipated to be gigantic, or a number could be anticipated to be very precise. So for example, if I had a column in a table that asked, how many children do you have? It would be rare that somebody would reach double digits in that column, right? Most people will have like one or two kids, maybe three or four, or if they're ambitious or Catholic, might be seven or eight, you know, or I do have some friends that have families that are much larger than that, but they're anomalous, right? It's not the norm, right? So you can anticipate that the numeric size would vary depending on the type of information being sourced. So this is one of the challenges of when you're building a database, is to decide the data type, the capacity of the data type, and how it's going to be used, right? All right, so they're pointing out here that there's three main data types: string, numeric, and datetime. Those are the primary ones that we use. That is not all that's available, though, right? One really interesting little tidbit, and without like going into a deep talk about what it is that modern MySQL databases, for example, can hold what we call JSON data, JSON, which is JavaScript object notation, which is a complex data structure in itself, right? And that can be housed in a database. Okay, why do they do this? Because so many websites now use JSON as the mechanism for transmitting data from one system to another. And MySQL is the primary database used behind most dynamic websites, that they found it a necessity to add that capability, right? So this is a kind of an interesting little sideline, but all right, we'll come back to that later. All right, let's look at first the string data types, which are basically the ones that hold letters and words, right? And there's a number of different ones, and I'm just going to like kind of scroll through them. Yeah, if you thought there was maybe one or two, like how many different data types do I need for words? Well, it depends. Is really the answer. There's a couple of in here that are actually complex data types, but let's look at the fundamental ones. So the most fundamental of all the data types for characters, or I guess we'll call it strings, is the character, where basically it is really, really small, right? It's a fixed length string. And then the size parameter specifies the column length in characters, which can be up to 255. Now, in a lot of situations, that's more than enough. But there is a cap, right? So for example, if your database is holding like I don't know, my verbose text messages, which go pages sometimes, it wouldn't fit in there. It might hold a basic text message, but it wouldn't really, fit a long one, right? Normally, though, when you have a character data type, the assumption is that you're only storing one character. This is kind of weird. If you're storing something larger, what you would normally do is you would put the size here. So how many characters is it storing? Okay, I'll give you an example. This might be a good data type if you have a column in your table for the state. States can be abbreviated with 2 letters. So you could use character parentheses 2 for your states. That would be a possibility. Okay. The other one that we see that's actually probably the most used string type is what we call varchar. That's how I say it, right? And really what it means is variable character size. And notice you can go from 0 up to 65,535, right? And you can declare the size here. This one I think is considered to probably be the most useful and flexible of all the character types for whatever reason. When I think about putting strings in a database, this is the first thing I think about. Doesn't matter what the size is, because I don't know if you've noticed, but if I could do character of size 2, I could also do varchar of size 2, same difference, really, right? The reality is this one would operate more efficiently. This one dynamically adjusts, but if we cap it at a size, in essence, it becomes as efficient, right? So I'm going to say that as in terms of strings, this is the one you're going to use most of the time, right? And this is probably where your brain will go to most of the time. There's a couple of other really weird ones. All right, so let's talk about these. We have the binary, which is equal to the character one, but stores binary byte strings. And this is highly specialized usage. So in other words, it's grabbing the information out of the database in its binary format and then storing the binary value of it. Now, this is super geeky stuff because the question should be in your brain, well, why would you do that? Right? Because really, the reality is when we are storing it in memory or storing it like on a hard drive somewhere, it does become binary to begin with. The concept really is that you're not doing conversions. Every time you're converting it from the binary format and putting it on the screen so you can see it as text, there's a processing hit that happens. If you have a bunch of data that remains binary and it doesn't have to be going through that process, it saves on a little processing power. This was more of a concern in the past than it is now, because now we have, much more robust CPUs, faster memory, faster hard drives, everything's faster, right? So we don't think about it as much. But so these two are kind of the clones of the two above, but keeps all the data in binary format. I'm going to say these are very limited usage, for at least at our level, super rare to use. I would even say even professionals would rarely touch those. Then we have these, we're going to learn about these large objects, right? Which we call lobs, basically. And when we're storing a large binary object, it becomes a tiny blob. Okay, whatever. Another nomenclature that kind of gets transported forward from other database structures, by the way, if you're curious, are tiny text, which is like a car, and text, which is like a varchar. So therefore, I rarely use these, right? Real frankly. Then we have the blob, which is something you might use. And I don't want you to confuse the 65,000 number with the one up here, which is the number of characters. This is the amount of bytes of data. So this could hold something significantly larger, because one byte of data holds one, let's say one byte, okay, one bit of data, one byte of data holds one character. So you can kind of extrapolate on that. But this is if you're using a very large size piece of data. We also have what we call medium text, and you'll notice like how many characters that holds, right? A medium blob, long text gets even longer, and a long blob. Now these I would call special usage. So if you're expecting somebody to type, paragraphs and pages and pages and pages or whatever, or you're maybe building a website that requires a large amount of text on the page, you might revert to using these. But I'm going to say that those are also pretty limited usage. So to kind of break this down, the two that you're probably going to use the most are these, and most of the time you're going to skip the first one and go right to varchar. It's the bottom line, right? When your stuff gets really large and you reach a memory capacity, then you start looking at the medium text and long text as an option. Right, so that's the practical usage of it. Now, they have a couple more interesting ones in here. And the first one is what we call an enum. And really what that means is enumeration. But it's a complex data structure, meaning that it's basically, without having taught you guys what an array is, but it's a collection of string objects as opposed to a singular one that I can put into a list The list is basically sorted in an order. The order can then be referred to and used to do other things. For example, we might have an enum in a table that might have, I don't know, tax code brackets, for example, something weird like that. Like, what's the limit of a tax code? And there might be 15 values. I'm not really sure what the values are these days for tax codes because they change so much, but that way it's kind of a list of values that we might look up. And tax codes is not a good example because that's a number. Okay, so maybe an enumeration could be all the NFL football teams. That might be a better example because it is a list that doesn't change, right? So, well, it doesn't change often. So that might be a good example. Another one that's similar is what we call a set. There's a difference between an enumeration and a set. A set is a little bit more freeform than an enumeration. An enumeration has structure and order to it. A set is a little bit different. But these, I would call these complex data structures, certainly beyond the scope of what we're doing here today. The next major category is the numeric data types. This also, and I'm just going to do a quick scroll on this, has a number of different types. And if you guys remember, like studying, like basic number theory and stuff in mathematics, you kind of don't think of numbers as being multiple different types. But the reality is, numerically, things break into categories. And when we're trying to store information on a computer, knowing, once again, the size of the numbers you're storing, it becomes really, really relevant to efficiency of how the database operates. So one of the basic, most low-level ones is one that we call a bit. And notice that it can hold a value from 1 to 64. No negative numbers are included. And the implication here is that it is a counting number or an integer. Right. The next size up, the tiny int, holds up to 256 total values, and it goes from -128 up to 127 as possible values. Also pretty limited, so you'd have to really have a functional reason to use this. It does help save on storage, though, because it uses less storage. Now, this is kind of weird because in most programming languages, we think of bool or boolean as a true false, and it doesn't really fit into the number category. But in a database, it does. And the reason why is, in a database, when we store boolean values, we store 1 as true and 0 as false. Compare that to Python, for example, which many of you guys are taking. In Python, we just say true as true and false as false. That's not true with databases, though. Databases will store true false as ones and zeros, 0 being false, 1 being true. They have 2 different naming conventions for it. Both are valid. Right. From there, we look at all the integer types, and we already had the tiny int, but then we have small int, medium int, and int, right? And we've kind of seen this one in action. And I want you to notice with all of these, there is a size that you can declare if you wish, right? If you don't declare a size, then it just uses the full range. So small int can encompass these numbers. A medium int can encompass these, and a standard int will encompass these, right? All of these will use also this thing saying unsigned range. So if you don't use minus marks, you can just stay on one side of 0 and utilize the whole range on the other side of 0, right? The positive side of 0. Notice there's also a big int, right? And that gets much, much, much larger. This is probably what they use for the national debt or something, right? And the interest rate on it, I'm just teasing a little bit, but yeah. And actually, they wouldn't use an integer for that. They would use a floating point number. Or you can stay on the one side of the 0, so on the positive side of the 0, and go up to that number. This is pretty huge. This is a large amount of information. From there, we move to the floating point numbers. That's where we have a decimal point in the number. And basically what we can declare is both the size and the number of digits in the floating point number after the decimal place, right? So whenever you see a float, a double, for example, and they have this little D here, so I might declare, for example, a floating point number that's 10 places large with 2 places after the decimal point. That I might use that for financial calculations. The floats and the doubles are basically similar, right? And I want you to notice here the total number of digits for floats is specified in the size, right? And then we go down to a double, we call this a normal size floating point number. The total number of digits is specified, So when I look at this, I go, what's the difference? Right? This is kind of the thought. Part of it is the fact that we're moving away from this generic term of float. So I don't know if you're noticing this. It says this syntax is deprecated in MySQL version 8 and above and will be fully removed in future versions. So if you're building a new database, you don't want to use floats, basically. The smart play is to use doubles, basically, or decimals. The difference basically between a double and a decimal is the decimal is an exact fixed point number, right? And it basically allows for greater precision. Another, by the way, a truncated way to say decimal is shown here. I will also show you that they have this weird thing called double precision. And I'm noticing they don't have a description on it. That's kind of weird. But basically what double precision is the equivalent to decimal. So maybe that's why they're not doing a description. I wish they would say something about it here, but they haven't. All right. Let's move on to date and time data types. All right. So as with the other data types, there's a number of different date time data types, and how the information is stored and captured is really kind of, once again, relevant to what you're doing. One thing that you'll often see in a database that automatically tracks you, for example, let's say like you sign in to Facebook. My bet would be that somewhere in their database, they have a timestamp that gets recorded every time you hit the database or hit their login, right? That says, oh, you signed in on this year, day and date, hour, minute, and second, precisely, right? And so like what level of precision you need is kind of interesting, but the timestamp one is one that you put in, and the moment the database record is created, it grabs the time now on the server that's running it. And I want you to notice it also will indicate like based on the universal time clock, and sometimes the time clock will have an offset set on it as well. And just to kind of, so you understand this, where is the central point on planet Earth where we chronicle time? This is kind of has anybody ever heard this before?
Greenwich, England.
That is correct, George. Greenwich, England, right? So in Greenwich, England is like, that is the 0 spot for the universal time clock. If you're east of Greenwich, England, we say universal time with minus numbers in front of it because they're ahead of the universal time clock, right? So if you get all the way across Asia and into the Pacific, where we have the universal date line, like in the middle of the Pacific Ocean, that's where first becomes tomorrow. So for example, right now it's already tomorrow in Japan, just to give you an idea. When we are west of Greenwich, England, like we are 6 time zones over from Greenwich, so we're a +6 on the universal time clock, by the way, right? Okay, so that's the timestamp thing. but you will notice that that is automatically initialized and updated, right? Whenever a record is created in the database. Otherwise, if you are using a date, so you're recording maybe somebody's birthday or the date of an event or a contract date or something like that, the date format by default uses the international approach of year first, month second, and day third, which is not our normal way of displaying it here in the US, right? So here in the US, we usually do month, day, year. And if you go over to Europe, they do day, month, year, by the way. So to put it in the database correctly, though, why do they do it like this? Why does this order make sense to do? Well, if you were to organize your dates numerically, right? Year would come first, then you look at the month, and then you look at the date, and then in that order, right? So it makes sense to store it in that order, even if we don't read it that way. So this allows the computer to basically do math on it, and you know, for example, set a range of dates and have it operate numerically within a range. So in essence, really, the date time is kind of a number in and of itself. You know, so just keep that in mind. You have just the standard date approach where we're just, you know, grabbing the year, month, day. You have date time, which also will throw in hours, minutes, and seconds, right? And so, for example, you know, you would have your year, your month, your day, then which hour and minute and second. And notice that the timestamp is in a 24-hour clock format, not in a 12-hour clock format. So there's no AM or PM. You have to calculate that, right? So that's kind of useful. The other thing is that you can do just a straight up time, hour, minute, second, and it will support kind of like a really weird range. And I'm not really sure why they do negative times, but there must be a reason for it. Or you can just focus in on the year. I think typically, like if you're doing a database entry or storing somebody's birthday or date of registration or something of that sort, usually you're using date or date time. Or if you're doing it automatically, like let's say on a login or when was the record created, we want a timestamp, that is generated automatically, typically. All right, so that's the major data types. What I'm going to do next is I'm going to switch over to MySQLTutorial's kind of overview of the same stuff. And I'm not obviously going to talk about the stuff in depth, but I'm just giving you a different view here because I think it's important to kind of have different viewpoints on stuff. All right, so the one thing, and our author gets into this too in some strange ways, but I do like their table, which is one of the reasons why I bring it up. So, you know, the stuff that you see on the screen here is probably the stuff that gets used the most in database work, right? In terms of commonly used data types. I'll just put it like that. And having a nice little table that shows the capacities all in one spot, I think is pretty helpful. All right. Once again, they show all the same ones that we just looked at. They talk about the Boolean type, the string data types. Each one of these has a little breakout page, so you can go read in depth on it if you wish. That's the other reason why I'm showing you that. The W3Schools one, I don't think they do that, do they? No, they don't. So that's one of the reasons why. So for example, if I wanted to dig in deep on varchar, I could go here and they talk about it and give examples. And I would encourage you, by the way, to check that stuff out. Okay. The other reason why I go to this site is because this one also includes some data types that W3 is not talking about, but that MySQL does now support. And I think some of these are really interesting because they are being used a lot in modern development work, especially app development, mobile apps, and websites, right? So I want you to take a look. These are the spatial data types. So this is kind of a new category, and it's really all about geometry. I mean, it's really kind of what it boils down to. I mean, in terms of being able to map coordinates, to declare a set of coordinates in various formats, right? And I'm just kind of reading through these to be able to declare shapes in their kind of like formatted form. This is really without going into like the details of like how GUI works and XY coordinates and all that stuff. I think these are really interesting that they've included these. This is a kind of a brand new thing, but it allows us to do some really sophisticated programming, because really what we're seeing here, folks, is complex data types that are used to do really sophisticated things in applications. Way beyond the scope of this class, but I'm just putting it on your radar so you're aware that it's out there. And if you get to the point where you're coding for something like this, you'd probably have the reason to and the knowledge to do it. The other one that they throw in here at the bottom is talking about this JSON data type, once again, which stands for JavaScript Object Notation. And I don't know if they have an example of it here. I never did click through on this, but okay, so they have all the little JSON functions. But I'm going to just do a really quick little example of what JSON looks like here. And so I'm just going to kind of bring this up on the screen, but this is JSON data that you're seeing on the screen. And it's basically data that travels in what we call key value pairs. So for example, here's one key value pair, a title, right? So this would be thought of as kind of like the column information. And this is thought of as the data for the column. And this is a very complex looking one. But basically, this is a way that a lot of applications now are talking to each other. So like one application will run a query on its database. It will extract the information as JSON data. This is kind of like a table of information. And then that data can be transmitted to another application that reads it in and converts it into its own table format. But MySQL now supports this as a data type, meaning it can store this information internally as JSON. And this is really, really important, you know, especially for application development, since JSON has basically become, I'm going to say, one of the more universal ways of transmitting information from one system to another when you're coding. All right. And I'll leave it at that. If you are curious, right, and you kind of go into this create table thing, whenever you sit there and you create a table, you're always going to name your column, consider the data type, and then set constraints, if any. But those two pieces of information, what you're naming it and what the data type is, these are critical, right? All right. So that kind of breaks down the, let's call it the reference material for this chapter. What I'm going to do really quick is I'm going to jump over to the author's slides here and hit on a couple of key slides. Then when we're done with this, we'll take a break, come back and start working on the exercises, by the way. Now, these PowerPoints make a whole lot more sense if you've read the chapter, so I'm just kind of putting it out there. But they are talking about basically in terms of kind of stuff that you'll do is to create queries that convert data from one data type to another. A lot of times just for display, by the way. So like you might take a weird numeric format and then concatenate it to a piece of text so that your output is beautiful. That's one example. But also to understand what kind of stuff goes in to certain types of data, which I think we've done already. And then they take a look at enumerations and sets. And once again, I would call this a more advanced skill that usually hold collections of information is the good way to say it. So generally, you know, they're looking at stuff falling into these data type categories. So this is kind of an interesting, I guess, counter view from what we just looked at, because with all the other ones, they did have the characters, the numbers, and the date time, but the large objects were kind of bundled into the characters and the numbers. But here they're saying it as a separate data type because in essence it is, because it's storing binary information, right? Um, Interestingly, binary information can really be about anything. This is where it gets kind of weird. So I could take, for example, executables and store them as a binary in a database. This kind of gets deep, right? Especially if you don't understand what those concepts are. And then they once again show the spatial and the JSON, which are kind of newer features. They go through and they do a lot. And you know what? I don't know why it like doesn't like all the right tab stops here. Not like I want to go fixing all their tab stops, but maybe it's because I'm looking at it in Google Sheets and I'm not looking at it in PowerPoint. But basically what these tables do is they show you the original value that you're entering in or is sent in by a query, what value actually gets stored, and then how many bytes of data are used, right? And they show basically when you declare a certain size, is it actually occupying that whole size? This is really kind of an interesting question. So the biggest takeaway I'd say from this slide is if I have a character with 2 places, well, that uses 8 bytes, right? So in the past, we would have thought this efficient. If I had a character string of 10 and I put the same 2 characters in it, well, it's occupying all 10 characters in memory no matter what. So it actually would occupy 40 bytes. You can see that this is getting inefficient. I'm only storing 2, but it's keeping 8 of them blank, if you feel where I'm going with that. So it's wasting memory in the database, right? This is why we use varchar almost exclusively, because this just looks at the actual size of the data and only occupies 3 bytes. So this really is the more efficient way to do it. And this is why database people almost by default always go to this as the tool. It stores the size that it is and needs, as opposed to storing the size that it could potentially be. You guys catching that difference? Right. And we want our stuff to work quickly and efficiently. So varchar really is the preferred tool of choice. They talk a little bit about this. This is kind of interesting about the encoding that goes into a database. So often when we're working with a database system, and I don't think MySQL Workbench shows it really efficiently, but there are basically what we call these character encodings, and I'm highlighting the UTF-8 here because that's the most common one. There's also the Latin character set. This is a little more basic, and the Unicode standard. But out there in the world of coding, when we talk about UTF-8, UTF-8 is kind of the universal character set that's used for a majority of everything that we do on a computer. All right. And if you want to read the background on this, please go ahead. But it's capable, the UTF-8 character set is capable of encoding. And I want you to notice how many characters it can encode, right? So it's not just A through Z, upper and lower case with numbers and special symbols, like all the stuff you get on your keyboard. It can encode a whole lot more. And it's kind of crazy what it can encode. And what I'm looking for here is maybe a breakdown. Of course, they don't show it. Somewhere they have to have a complete table. But if you looked at, like, for example, a font map with UTF-8, what becomes really fascinating here, let me do it like this. UTF-8 characters. This might be better. I'm looking for a concise table, but basically what they're showing you is that you can have all your basic keyboard characters, as you see, right? So then you have extended Latin letters. So if you have umlauts and accents and underscores and weird languages that use these forms of the letter E or whatever, that's built in too. And then you can go further and further, and I'm just going to hit on a couple of these. So you can have things like these like weird characters that we use. Most of these are on our keyboard. Boy, it doesn't like that. Okay, fascinating. I'm getting spammed by W3Schools now. Okay, so here's where it gets even weirder. All of the Greek characters are encoded, right? So that's good news for me if I want to do like a multilingual website. Um, Cyrillic, which is similar, currency symbols, letter-like symbols, number forms, arrows, mathematical operators. Let's give you an example, right? All the little symbols that you see in math, that's all encoded in there too. And it goes further and further and further. But ultimately, it contains most of the world's major languages, and numbers, special symbols, and things that you would never even think of, right? That are included in UTF-8. That's kind of my grand point on that one. All right. So not to go down that rabbit hole too far, but if it can be, your database can be encoded with the character set, that means it's allowed to hold those characters in the database. And that becomes kind of a choice, right? So they go through their version of describing all the different integer types. I think we already did that, right? They show comparisons of, how much stuff is stored and what value is displayed in the storing, by the way. Some of these are kind of oddballs, so I wouldn't worry about it too much. They talked about fixed point types. So for example, basically decimal numbers, doubles, and floats, right? And you'll notice how they kind of push float all the way to the bottom because it is being deprecated. So really what you want to use generally is decimal. That's kind of the preferred format, or doubles, right? Now the reason we, often we'll use decimals, and this is a really common declaration, by the way, because that holds up to 1,000,000 plus, right? So that's the range it gets into, and two digits after decimal point, often used for currency. So some things that they have you consider about when you're working with numeric data types, and I'll say the same thing I'll say to you guys as database people that I say to my programmers, like what numbers are you working with, the size of the numbers, the scope of the numbers, what they're used for, all that. Often when you're working, especially in a team environment, that's usually determined by like an engineer, a scientist, an actuary, an accountant, or somebody like that, right? And they'll say, hey, I need to have this many digits and it's got to be this precise. And and the kind of stuff that we're going to work with are like, dollar amounts, account, that type of thing, a date time, so it'll be a lot simpler. But these things are important, especially if you're working with those higher level people. They start talking about the date time things. We looked at those too. They show examples, right? So you see how fast I'm going through this. And then like if you enter a value in, I think this is kind of interesting how MySQL sees it. So if I enter in 7:32, MySQL sees it as that, right? This would be for time, right? And they just do little comparisons like that, like you might get that timestamp in there, but the timestamp is a timestamp, by the way. All right. Then they start getting into the enums and the sets. And once again, I call these higher level or complex data structures or collections, technically, where they hold multiple values. Like, for example, I might have a set that has pizza ingredients, right, that you might be able to choose from. So you could imagine you might build an application that might have a set that shows all the possible pizza toppings. And then people can select from that set, right? So in other words, the one column in your database holds an object that has many values in it, right? Python people, we haven't gotten to the chapter on arrays yet, although we kind of started doing it with strings a little bit, right? That's kind of the correlation. But even in Python, we'll talk about the concept of sets as we move on. They talk about these binary types of really large objects, the blobs, the binary large objects, and the character large objects. Those have very, very simple usages, or rare usages is what I meant to say. I apologize. All right. Another thing that we're actually going to do as part of our activity tonight is we will be doing some conversions. So, for example, if I want to show the total of an invoice and then I want to take that total and I want to display it in a way that looks nice, I might want to put a $sign in front of it. So I would run our concat function to append a $sign to whatever the invoice total is, so that when I output it to the screen, it looks, kind of nice, and you can see the actual dollar amounts there, right? So you can convert from a number to a string, or you can convert a string to a number. This is kind of weird. I can give a couple of examples here. And then you can also convert a date to a number. That's particularly strange, I think, because, is this really the same thing? It's not, but it is doable, right? It's something that does happen in database stuff. We also have this thing called a cast operator. And basically what a cast operator does is it converts one data type to another based upon what you're trying to shoot for. It's really kind of the best way I can really explain it. So in other words, you can use any of the data types that you see listed at the bottom there, and then you can cast to other data types from those data types. Just as an example, you could take an invoice date and cast it as a character, right? And then when you look at the output of that, right? And I'm just going to move this so you can kind of see the code. So you're taking the invoice date as a character, right? And then that's coming out this way. So now you're not, what you should say is, why would I do that? Right? Because it's basically the same output, except this is a string of characters. This is a data type in the database. So if I'm actually pushing it out to an application to put it on the screen, this might be more useful. This might be something I would push out to a website. This might not push out to the website correctly. That's really the why. Also, you can take the invoice total, which is, in dollars and cents, and you can output it as a signed thing, meaning we're not worried about the precision. We're just outputting it as a signed integer, and it truncates the remaining data. So these are, real frankly, primitive examples, but we'll see how that works in a little bit. They also have these format and character functions where you can basically, these are almost always used to do what we're seeing here, which is like, for example, you might have a number that's like this, but you need to convert it to currency, right? So you format it to 2 decimal places. It drops in the commas, it drops in and rounds to the right amount, right? So I think the formatting command can be very useful. For example, if you're calculating dollar amounts from raw values, right? Because maybe it costs you 1,000th of a penny to produce a product, right? And you add a whole bunch of them together, and eventually you get to the point where you're rounding it, and you would format it, right? The same thing happens with the character thing. So if you are now this is a function for character, not the data type, and I don't want you to confuse those, but you can set up basically the function, and then you have what you call the control character, and then it allows you to basically control your output so it looks a little bit neater, is really kind of what's going on here. So you have concatenation of the vendor name, character 1310, and then the vendor address, right? And what this is really doing is it's putting in what from this chart here, right? You can tell 10 is a line feed, and then 13 is a carriage return. So in other words, we're putting in the vendor name, we're doing a carriage return going to the next line, and then we're doing a line feed to move to the next line below that. Okay, so these are kind of weird ones, but that ends my little lecture here on the author. So I'm going to stop the recording here.